In this question, we've been told that a particle is projected from a point O on level horizontal ground with a speed of 28 meters per second at an angle alpha to the horizontal, where tan alpha equals 3/4. Okay, so we've got a projectiles questions. It's been projected at an angle, so it's a 2D projectiles question. Let's just set up our diagram. The particle started from level horizontal ground, so there's no platform for this question. Here's the flight path, the expected flight path, and here's the original angle of projection with a velocity of 28 meters per second. Okay, I'm just going to quickly add on the components for that initial velocity. I have 28 cosine alpha and 28 sine alpha. We were also told that tan alpha is 3/4, so I'm going to quickly draw a triangle for reference. It's a 3-4-5 triangle, so I can get an expression for sine alpha and cosine alpha, which I'm anticipating using throughout the question. So 3/5 and 4/5 will be used throughout the question. Okay, so let's continue reading. We're told that it's moving freely under gravity. That's what we expect. We're told it reaches a greatest height before it lands on the ground. So we do know that this particle comes and impacts the ground. In part A, we're asked to find the time it takes to reach the greatest height above the ground. We know that at that point, the particle's current vertical velocity is going to be 0. It's instantaneously at rest if we're only thinking about the vertical direction. So let's bring up our vertical Suvat variables, and we're going to set the current, or the new velocity, to 0. So what do we know? We don't know the displacement. We do know the initial vertical velocity is 28 sine alpha, and sine alpha is 3/5. We're waiting for the final velocity, the current velocity, to be 0. We know that acceleration due to gravity is negative 9.8, and we're looking for the time it will take for this situation to happen. Okay, so the 4 variables we're working with are u, v, a, and t. The formula to use is v equals u plus at. Substituting in, we get 0 equals 28, 3/5 minus 9.8t. And let's just rearrange to make t the subject. This is the fraction I'm going to put into the calculator, and I get 1.71 seconds. That's the time that it takes for this particle to get to that highest point on its flight path. Part B of the question says that we should be able to use that to find the distance OP. Okay, well, we do know that the time that it takes to get to that highest point, because of symmetry, is also the time from the highest point back down to the ground again. In other words, from O to P is going to be double the time from O to its highest point. So we can just double that time, and then we can think about how far will it go horizontally in that time. So let's collect some horizontal Suvat variables. So what do we know? We don't know the displacement is what we're looking for. The initial velocity, 28 times 4/5, and the same for the final velocity. Acceleration horizontally is always going to be 0, and the time, just like I said, we've doubled that time to get 3.43. So that was the time, the full answer on my calculator. When we double that, we get 3.43. So the formula to use here for the horizontal displacement, there's only one that we need to use, and that's S equals ut. Displacement is going to be the initial velocity multiplied by the time. So in this case, we've got 28 times 4/5 multiplied by that time, 3.43. And that gives us a distance of 76.8 meters. So the horizontal displacement from O to P, 76.8 meters. The question goes on to tell us that the particle reaches a height h meters above the ground 1 second after leaving the origin, and we've been asked to find that value of h. So once again, we're working with our vertical Suvat variables, and let's just collect the ones we know for this mini journey. So displacement is unknown, we have our initial velocity again, final velocity is unknown, acceleration remains negative 9.8, and the time, as the question has asked us to work with, is 1 second. So how high off the ground will this particle get in 1 second? So the formula to use here, S equals ut plus half at squared, and then we'll just substitute our values in. So we have our initial velocity, 28 times 3/5, time is 1, that's an easy one to substitute in, and obviously our acceleration. Into the calculator, that gets us 11.9 meters. After 1 second, this particle will be 11.9 meters off the ground. Part D of the question says hence, as in using that information, calculate the length of time for which the height of the particle above the ground is greater than h. Okay, so to find this, we'll look again at the diagram and we're going to mark off where h would be. So here's the height h, and the particle is going to be at that height at 2 different times. So the first time is after 1 second. We just need to find the second time that this particle is at that height. The difference between these 2 times is how long it was above the height h. Okay, so we can go ahead and use the same variables we worked with before. So the vertical, initial velocity, 28 times 3/5. Acceleration is negative 9.8. So I'm going to go ahead and use the same formula and expression that we had before, but I'm going to set it equal to 11.9, and I'm going to use an unknown time. I'm trying to solve what time is the particle at this specific height off the ground, this specific displacement off the ground. So we'll just have the variable t, and displacement is 11.9. Okay, we can just tidy this up. And at this point, we should be able to put this into our calculator, but I have spotted that this factorizes. They're not the nicest numbers to use, but it does actually factorize into 4.9t minus 11.9 and t minus 1. Okay, that leads to 2 answers, 2.43 and t equals 1. Well, we already knew that it was going to be at that height after 1 second. It's also at that height after 2.43 seconds. So the time in between them is how long it was above that height. So 1.43 seconds, it was above the height h, which is 11.9 meters.